Algebra 1, Lesson 61, Subsets and Subsets of the Set of Real Numbers. Before I start talking about sets and subsets, let's talk about the tree of numbers. So we're only going to be talking about real numbers. We're not going to be talking about unreal or what are considered imaginary numbers. So if any of you have heard of unreal or imaginary numbers, we're not talking about those. So the set of numbers, which is all the numbers we deal with, we have real numbers, right? Real numbers includes just about every single number that we use. Positive numbers, negative numbers, decimals, fractions, pi, stuff like that. So real numbers is broken into two major sets. The two major sets are rational and irrational. If a number is rational, it cannot be irrational. If a number is irrational, it cannot be rational. However, these are all real numbers. Irrational numbers are things like pi. They're numbers like the square root of 5. And what determines an irrational number is if it is a decimal number that does not repeat its digits infinitely, which means the number has no end. Yes, the square root of 5 has no end. Neither does pi. Square root of 7 is another one. Square root of 23. So irrational numbers are pi and then square roots that are not perfect, so imperfect roots. Now let's go to rational numbers. Rational numbers include, the basic rule of thumb is a rational number is any number that can be represented as a fraction with whole numbers. So that includes positives, negatives, includes and repeating decimal numbers. So like 1.333, that is rational. That's different from pi because pi, the numbers do not repeat. Here, the numbers do. So that would be like 1/3, right? 1/3 is equal to 0.3 with a line over it. Okay, so repeating decimals are rational, and then anything that can be written as a fraction is rational. So, like -4/5. Now, rational numbers are also broken up into groups, but rational are broken into 3 groups. The first is natural numbers or counting numbers. So natural or counting. And that is 1, 2, 3, etc. I should have separated these more. I'll just go farther down. Next, we have whole numbers. And whole numbers are just like natural numbers, but they include 0. So you start from 0. Now remember, natural or counting numbers, they don't have 0 because you don't ever start counting items by saying 0, 1, 2, 3, because then you'd actually have 4 items. And then the last one is integers. Now integers is all negative numbers, all positive numbers, and 0. And those are all of our real numbers. Those are the numbers that we're dealing with here. Now we have to learn how to put those into groups. So let's find some examples here. Let's start with 11/6. This number, it is a fraction. So it is a real number, right? Because that works. Let's fix this focus here. Okay, so if we take the number 11/6 and we compare it to our chart, 11/6 is real. Now, is it irrational? No, because it can be written as a fraction of whole numbers. So it is real, it is rational. Now, is it a natural number? No, because it's a fraction. Is it a whole number? No, it's a fraction. Is it an integer? No, it's a fraction. So 11/6 is just a real rational number. So when they tell you to group the set of 11/6, you would write 11/6 is the set of real, comma, rational, and set. And that's set notation. We'll go over that in a second. And then, so just based on what numbers you're given, you should be able to go through this chart and figure out which group it falls into. Now let's talk about subsets. So there's set notation. And there's two ways to do set notation. One is this like pitchfork thing that looks like a backwards E, and the other one is just this sideways U. These two signs show set numbers. Now, the pitchfork thing just pretty much says that this number is a member of. So the pitchfork is like saying 11/6 is a member of real rational numbers. Now, this is used to show subset groups. So the way we'd use this is we would say that the subset of rationals, I'll just put RAT, is in the group of real numbers. And what that means is that the group of real numbers contains rationals. And then another way we could do this is we could say that integers, I'll just put int, is in the set of rational numbers. So that's how those sets work. Now, the book will give you their own made-up sets. A good example of this is on practice A. They say, given the sets of A, B, and C, which of the following are true and false and why? So the first one they ask is the set of B inside the group of A. So if we look at B, we've got the number 0, 2, 4, 6, and the set is complete. So B includes is talking about these four numbers. Can we find those four numbers in the group of A? Well, A has 0, it has 2, and if it repeats, it will have 4 and 6. That's what those three dots mean. So 1 is true. Now let's go to 2. Is B in the group of C? Well, if we look at the group of C, there's no 0. Also, C only has odd numbers, and it's only got these four numbers. So are these four numbers in that group? No, they are not. So this one is false. This is not true. And the reason why is because set C only has odd numbers, or set C does not have any of the numbers in set B. Now the last one, is set C a part of set A? Yes, it is, because the number 1 and 3 are there, and if it repeats, we will definitely hit 5 and 7. So that one would be true. So that's set notation. That's how you use it. That's how you read it. And then the sets are always written inside these braces, which we know as funny mustaches. If you have any questions, let me know on Moodle, and I will see you in class.